Hello everybody. Okay, so in this video we're looking at proof by induction, but more importantly we're looking at the inequality proofs of induction. So what does that mean? Well, it's just a proof by induction, but now we just have to prove that my left hand side is always going to be greater than my right hand side or less than my left hand side, whatever the question asks us to do. So there's a key thing we need to do for these ones, and we need to use kind of this property of inequalities, right? So the thing we need to prove, right, is we need to prove A is greater than C. That is what we need to prove, right? We're gonna be using our assumption in the question, right, to prove that A is greater than something else called B. And then the final step would be we prove that B is greater than C. And then once we've proven that, if B is bigger than C, or B is greater than C, and A is greater than B, therefore we could prove that A is greater than C. So we'll have a look here. So prove 3 to the n greater than n squared is greater than n squared for n greater than or equal to 2. So prove for the smallest value of n. So prove for n equals 2. That's the smallest value of n here. So 3 squared is greater than 2 squared, which is 9 is greater than 4. True. Assume true for 3n is greater than, assume true for n equals k. So be 3 to the k is greater than k squared. And finally, we need to prove, and what we're trying to prove is, we're trying to prove 3 to the k plus 1 is greater than k plus 1 squared, i.e. we're trying to prove here now A is greater than C. This is what we're trying to prove. So now we're gonna prove for n equals k plus 1. So using my assumption, right, I have 3 to the k here is greater than k squared. I'm going to use my assumption, and now I need to make my assumption here, my left hand side of my assumption, there's 3 to the power k, I need to make that look like 3 to the k plus 1. And how do I do that? Well, I multiply both sides of my inequality by 3. So I'm left with here on the left hand side, 3 to the k plus 1 is greater than, no, something new, 3k squared. So I now here have A is greater than B. So I'm looking to prove A is greater than C, and I have A is greater than B. So I need to now prove B is greater than C. So I need to now prove that 3k squared is greater than k plus 1 squared for n is great for k is greater than 2 or n is greater than 2. So I have 3k squared is greater than k squared plus 2k plus 1. Right? 2k plus 1. So what we have here then is, right, so we're going to show this is true. This is true for n is greater than 2, right? Because it's going to be 3 times 2 squared is greater than, right, 2 squared plus 2 times 2 plus 1. So 3 times 4 is 12. 12 is greater than 4 plus 4 plus 1. It'll be 9. Right? That's true. And therefore, this is always going to be true for n is greater than 2 because, right, I have a k squared here, but I'm just multiplying it by 3 over here, grand. And then I have a 2k plus 2k and then a plus a 1. So anything greater than 2 will work. So this is a true for all n greater than 2, therefore proven by induction. Therefore, now b is greater than c, therefore I can say then 3 to the k plus 1 is greater than k plus 1 squared. A is greater than c, so therefore proven by induction. For values of n greater than 2. Let's look at the other one here. Prove by induction, n squared is greater than 4n plus 3. So for n greater than 5, so prove for n equals 5. 5 squared is greater than 4 times 5 plus 3. 25 times 23, true. We need to assume true for n equals k. So k squared is greater than 4k plus 3. We're assuming that's true. And then we need to prove true for n equals k plus 1. So it's going to be k plus 1 k plus 1 squared is greater than 4k plus 1 plus 3. So this is my a is greater than c. I now need to, using my assumption, here, so my assumption is here. I need to make my left-hand side of my assumption look like my right-hand side. So let's kind of expand this out here. So my left-hand side here would be k squared plus 2k plus 1 greater than 4k plus 4 plus 3 plus 7. So I need to now use my assumption. I need to make my left-hand side of my assumption, right, look like this. And how do I do that is I add 2k plus 1 to both sides. So I'm going to have my k squared here. I'm going to add 2k plus 1 greater than 4k plus 3, add my assumption, add to my assumption 2k plus 1. So I have here now k squared plus 2k plus 1 is greater than 6k plus 4. So this is my a is greater than b. Now I need to prove that b is greater than c. So I need to prove 6k plus 4 is greater than 4k plus 7. So show that's true. Well, I'm going to have 2k is greater than 3. K is greater than 3 over 2. And is that true? Yes, it is true. True as n is greater than or equal to 5. So therefore, a is greater than b, b is greater than c, therefore a is greater than c. So I have here now k plus 1 squared is greater than 4k plus 1 plus 3, therefore proven by induction. Right, so let's look at another example here. So prove by induction that 1 plus x to the power of n is greater than or equal to 1 plus nx for n greater than minus 1. So we need to first show for n equals 1, because that's the smallest value of n. So 1 plus x to the power of 1 is greater than or equal to 1 plus 1x. 1 plus x is greater than or equal to 1 plus x. Ding ding, that's true. Next step, assume for n equals k. 1 plus x to the power of k is greater than or equal to 1 plus kx. Right, assume that's true. Now, finally, last step, we need to prove true for n equals k plus 1. So that is going to be 1 plus x to the power of k plus 1 is greater than or equal to 1 plus k plus 1x. So this is going to be my a is greater than c. Right? Now, using my assumption, so using my assumption here, right, I need to make my left-hand side of my assumption look like the left-hand side of the thing I'm trying to prove. So this is the power of k, this is the power of k plus 1. So this can be written as 1 plus x times 1 plus x to the power of k. So I'm going to multiply the top here by 1 plus x. So both sides. 1 plus k to the x. Right? Okay. So using my assumption there, so I now have 1 plus x to the power of k plus 1 is greater than multiply this out if you want to, or right? But it's greater than 1 plus kx times, let's multiply all, right, by 1 plus x. So that is my a is greater than b. So then finally, I now need to show b is greater than c. So 1 plus k to the x times 1 plus x is greater than 1 plus k plus 1x. So this is going to be 1 plus k to the x plus k to the x squared is greater than 1 plus k to the x plus x. Well, I'm just looking here. That will cancel here. That will cancel here. That will cancel here. So I have here kx squared is greater than 0, and is that true? Yes, it is true. As x is squared, so I'll be positive, and then multiply by a positive number. So the left-hand side will be positive. As k is greater than 0, and x squared is a squared term. So therefore, then you do a whole little spiel there. It's like proven true for n equals 1, assume true for n equals k, therefore proven true for n equals k plus 1, therefore proved by induction for all values of n elements of natural numbers. And finally, last what I'm going to do here is we're doing a factorial, right? So proved by induction that n plus 1 factorial is greater than or equal to 3 to the power of n. Again, so let's show true or prove true for n equals the smallest value of n. The smallest value of n could be is 5. So show that to be true. So it'd be 5 plus 1 factorial is greater than 3 to the power of 5. So 6 factorial is greater than or equal to 3 to the power of 5. Which is 243, and then 6 factorial. 720. So 720 is greater than or equal to 243. That is true. So now we need to assume true for n equals k. It'll be k plus 1 factorial is greater than or equal to 3 to the power of k. And finally, prove true for n equals k plus 1. So in my bracket here, I'm going to have then k plus 2 factorial is greater than 3 to the k plus 1. So this is my A, this is my C. So A is greater than C. That's what we're trying to prove. Now, using my assumption, now. So k plus 1 factorial is greater than or equal to 3 to the k. Well, k plus 2 factorial, if you remember, k plus 2 factorial will just be k plus 2 times k plus 1 factorial. So I'm going to use my assumption and multiply the left and right hand side by k plus 2. Factorial is greater than or equal to k plus 2 times 3 to the k, ding dong. So I now have here k plus 2 factorial is greater than or equal to k plus 2 to the 3k. Now this is my A is greater than B. Now I need to prove B is greater than C. So I need to prove now that k plus 2 times 3 to the k is greater than 3 to the k plus 1, right? So k plus 2 times 3 to the k is greater than 3 times 3 to the k, right? Them 3 to the k's will cancel here. So k plus 2 is greater than 3. This is true as k is greater than 5. So this is true as k is greater than 5. So my left-hand side will always be greater than my right-hand side. Therefore, proven by induction, for x is an element of n. Or no, x is an element of n, sorry. For n is greater than 5, n is an element of natural numbers. So make sure to put your whole spiel there of proven true for n equals 1, assumed true for n equals k, thus proven true for n equals k plus 1, proven by induction. For n is greater than 5, n is an element of natural numbers. And so that's it. I hope this video was some help to you guys. And I'll see you guys later. Bye.